All right, hello everyone, and welcome to the Clean Water webinar series. We are so excited to be able to offer these webinars to our monitors, friends, and clean water community as a chance to learn about clean water issues and stay connected during these strange times. I'm Rebecca Shore, the Mid-Atlantic Save Our Streams coordinator. I have a few housekeeping items to review before I turn things over to our presenter, Dwayne. First, this webinar is being recorded and will be available on the Isaac Walton League YouTube channel soon. Keep an eye out on our website at iwla.org for information about the recordings and upcoming webinars in our series. You'll also get an email in a few days with a link to the recording as well. Second, if you have any questions during the presentation, you can type them and send it from the GoToWebinar questions pane. We're going to save time at the end for question and answer, so feel free to send those throughout the presentation and we'll get to those questions at the end. The webinar should run for about an hour total, which includes time for question and answer. All right, so with that, I'm going to turn things over to Dwayne Havorka, the Agriculture Program Director for the Isaac Walton League.
Well, hi. So I want to start and have you put on your favorite Imagineers cap. I just want you to imagine for a few minutes that you found a magic wand. You found a magic wand that was powerful enough to do some really cool things. It's powerful enough so you could point it at the Chesapeake Bay and you could clean up the bay, finish the job that we started decades ago to try to finish cleaning up the water in the bay. That you could point it at those nasty algae blooms in places like Lake Erie, South Florida, the Big Dog, the Gulf of Mexico, and the dead zone there. You know, bam, 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 they're gone. If you had that kind of a magic wand, you might point it at our bees and our pollinators, try to reverse the decline that we've seen over the past few decades, because we really need those pollinators for at least a third of the food that we eat. You might think about the floods that ravaged the central part of the country last year, and maybe you could think about what could we do to prevent some of those floods in the future. And maybe you're thinking about economic health too. And if you're from a rural state like I am, you might use your magic to help struggling family farmers reduce their input costs, keep as much of the food dollars on the farm and in those rural communities, create thriving communities where people want to come to those communities, where as many people want to come in as there are that want to leave. Well, if you got that kind of magic, you know, maybe you could do something even about obesity in this country, and maybe you could even reduce cancer. Maybe yes. So if you have that kind of magic, once you got good at it, you might want to use that magic wand on climate change. Maybe it's not big enough to solve climate change completely, but with a wand like that, you could sure put a big dent in it. But wait, you're saying, no, if there is a magic wand like that, a magic wand that powerful, wouldn't they be talking about it in Congress, in every state legislature, in local communities around the country, on every single farm and ranch? Well, yeah, they would. And it turns out at least some very smart people are talking in all those places and more about the magic of healthy soils. So soil health, what is it? Who cares? Did we lose it? Where'd it go? How do we get it back? What can I do? Well, stick with me in the next few minutes. I hope to show you the answers to all of those questions. That the answers are right there beneath your feet in the magic of healthy soils. But really, soil health, it really isn't about magic. It's about science. So first, a warning. Now, I'm not a soil scientist and I don't play one on the internet. I'm a political scientist. And let me tell you that political science is not an oxymoron, you know, like jumbo shrimp or jumbo shrimp. So everything I'm about to tell you could be wrong, but I have to tell you that there are a lot of really smart actual soil scientists and a lot of really smart farmers and ranchers who really believe this stuff. They're very smart people. They have years of research and actual on-farm experience to back it all up. They believe it, and that's why I do too. Now, I know you're going to have questions as you go along. Please send them to us. We'll answer them at the end. So let's get started. So did you ever wonder what plants do all the time when you're gone? Well, I know I do. I did. And then this virus thing came along, and then we're stuck at home, and I'm spending 24/7 with these guys, and I was really learning a lot about what amazing creatures plants are. You got all these beautiful green leaves, and that's chlorophyll. Those are solar panels on those leaves, and what they're doing is taking light from the sun. You know, sunlight, is it a beam, is it a wave, is it a ray? I think even Einstein was a little bit confused about that. But what we know is it's energy. And through the magic of photosynthesis, plants are taking that energy, they're taking carbon dioxide out of the air and water, and they're combining them to make carbohydrates. Carbohydrates. Now, the good thing is the leftovers in that process is oxygen. And that's good. So the plants give off the oxygen in the process, and we get to breathe that air. So we breathe in the oxygen, we breathe out carbon dioxide. The plants breathe in that carbon dioxide and they breathe out air. So it's a great system. And that's why when you think about the forests and the prairies around the world, we call those the lungs of the planet, because they're spewing out all that oxygen for us. So the next time that you take a breath, thank a plant. Namaste. So carbohydrates, what are carbohydrates? Well, they're sugars, right? They're sugars. It's an energy source. Plants use those sugars to build new parts of their plants, new leaves, new roots. They pump them into their leaves. They pump them down in the roots. But you know, they do something else with those carbohydrates, with those sugars that scientists recently figured out. Plants have been around hundreds of millions of years, and plants, well, they've learned a thing or two, including how to make friends. You know, everybody knows if you want to throw a party, all you got to do is offer free food and drinks. And, you know, friends you didn't even know you had will show up. So plants do that. They pump some of those sugars right through their roots and right into the surrounding soil. And not just a little bit, a lot. Sometimes 30 or 40% of the sugars that plants create, of those carbohydrates, get pumped right out of the roots and into the surrounding soil. What they pump out are sugars and amino acids. Well, why? Why would plants do that? Well, it's a party. And when good things show up to the party, bacteria shows up to the party. Some of these bacteria are kind of clingy, so they stick themselves to the outside of these roots and they form a protective barrier that actually protects those roots from diseases and pests. Some of the bacteria break down old dead plant material, all the leaves and dead roots, and that frees up the nitrogen, the phosphorus, and the other nutrients, and it makes them available in the soil to the plant. Some of those bacteria can actually take nitrogen out of the air. Did you know that air was about 78% nitrogen? Well, these bacteria take that nitrogen out of the air, they fix it in the soil where plants can use it. So those bacteria that call in whenever the plant pumps those sugars out through their roots, they do a whole lot of good things for their plant buddies. So that's why the plants pump out their sugars and amino acids. Those are called exudates. So exudates into the soil. Now, what else shows up? Well, mycorrhizal fungi also shows up to the party. Mushrooms are an example of a fungi, but there's lots of different kinds of fungi that live in our soil. They show up to the party because they also like those exudates, the sugars and the acids that plants are pumping out. Now, fungi in your soil are really tiny, so they're sometimes microscopic. They send out these hyphae, which expand and extend out. They're smaller often than even a human hair, so they're really hard to see. They can attach themselves to the roots and they can grow and spread. And what that helps the plants do is to reach out beyond where their roots are, beyond where they can reach. Now, those fungi actually bring nutrients like nitrogen and phosphorus and other nutrients back to the plant. They bring water back to the plant. They also even help defend against diseases. So those are all very positive things that these fungi do to help the plants survive and to help them thrive. Sometimes these hyphae, sometimes these fungi actually send signals. So when one plant is being attacked by a pest, the fungi carry a signal to other plants that can actually ramp up their defenses against that kind of pest. So they're ready when the pest shows up. It's amazing what we're learning about what plants do and what this life in the soil does as part of their association with plants. Plants can actually regulate the kinds and the amount of fungi in the soil right around their roots by changing the mix and the amount of exudates they release. If they want a certain kind of fungi, they start releasing a certain kind of exudate. So it's an amazingly complex, intricate, beautiful system that living plants and the living soil around them have evolved, and it helps all of them survive. It's a system that we know much more about than we did 10 or 20 years ago, but we still have a long ways to learn. So when we talk about soil health, what we're talking about is that life in the soil. Now, soil organic matter makes up only part of the soil. That organic matter, and that includes the fungi, it includes the bacteria, it includes bigger things like the worms and the nematodes that live there, along with the dead plant material that's in the soil. All of that organic matter can make up different parts of the soil. In a wetland where you don't have the oxygen there that helps break it down, sometimes that soil organic matter can be 20 or maybe even 30% of what's in the soil. In a diverse native prairie, you may have 10 or maybe 15% of your soil is that soil organic matter. In a well-managed cropland, that may be only 5 or 6% of the soil is organic matter. And in a degraded cropland, you may have just 1 or 2% of the soil is organic matter. The rest of the soil is made up of those minerals. It's sand, silt, and clay. But that organic matter, all that tiny bacteria, fungi, the worms, the nematodes, all the life in the soil, that's what gives soil its health. That's what gives soil its life. It's the most critical part. So, why should anybody care about soil health? Well, healthy soils absorb water like a sponge. So when rain stays in the soil, that reduces polluted runoff. When they absorb water like a sponge, that can also reduce flooding downstream. By holding more water in the soil, that helps plants deal with dry times or even a drought because you've got the water stored in the soil. And with changing weather patterns that we're seeing, heavier but less frequent rains, we're now seeing more of those 3 or 4 or 5 inch rains around the country, but they come less often than the 1 or 2 inch, those long soaking rains that we used to get more of. So that's a huge difference. Now plants do this, soil does this the same way a sponge does. You see all those little holes in the sponge. That's what helps absorb the water and hold it there. What soil does is that all of that bacteria, all the fungi, they work together to create structure in the soil. There are proteins in those exudates from plants. Even the fungi give off their own exudates, and these proteins are sticky and they help stick soil particles together. And what they do is they build structure in the soil. And that's really important because that provides spaces in the soil, pockets of air, pockets of water that can hold water, that also provides habitat for all those microbes that live down in the soil. If you take some really healthy soil and you take a look at it, what you'll see is a whole bunch of little air pockets and holes and crags. And if you squish it down, if you packed it all down and tromped it all down and got rid of all that, all those air pockets, all that water, in healthy soil, it'll squish down to about half the size that it was, because about half of the volume of really healthy soil is all those air and water pockets in there. So they're really important and they really help hold water, and that makes a big difference in terms of water quality and in terms of plant health. How big a difference? Well, so take a typical Illinois soil. that may be degraded to say 1 or 2% soil organic matter. A soil like that can maybe only hold a ½ inch or maybe an inch of rain before it becomes saturated on the top. Everything after that runs off. And when it runs off, it carries nutrients, it carries pesticides, it carries manure, it carries soil, and it carries all of that into your local stream and then on down into the river. That same soil restored to health with 5 or 6% organic matter could now hold maybe 3 inches of rain. So you get a heavier rain and all of it goes in instead of running off. And if you restore that to grassland and you restore the soil organic matter to something like 8% or 9%, well, that kind of soil has enough water holding capacity that it can hold a 4 or a 5-inch rain. So only a real big gully washer is going to carry any soil off of a well-managed grassland like that. So that's how much difference the management makes and how much difference that soil organic matter makes. Well, what other kinds of differences? Healthy soils produce healthier food. What we've seen over the last 50 to 70 years is a decline of at least in the range of 5 to 40% decline in the minerals, vitamins, and proteins that are in our favorite fruits and especially vegetables. That's really important because it means that the food that we're eating today is less dense in terms of nutrients than it was just 50 or 60 years ago. So healthy soils also require fewer inputs. That's true whether you're on a farm or in your garden. Healthy soil feeds those plants. Those systems that I described, the bacteria and the fungi bring nutrients to the plants. You know, plants have been living for millions of years and they didn't need us feeding them. And that's how they did it. They had those intricate, beautiful systems. So healthy soil feeds plants the nutrients they need. And if they're doing that, then they don't need extra fertilizer. In fact, it's just going to waste. Healthy soils also help plants fight off pests and diseases. That means you can reduce the use of any kind of chemical pesticides on those plants. Healthy soil also stores carbon. Now, exudates are a liquid carbon. That's carbon from the air, which is developed by the plants through photosynthesis. They pump it into the soil. So the biology in healthy soils continues to break down that carbon even further and further. And eventually you have humus. It's a stable form of carbon that can last in the soil for decades or even centuries if it's not disturbed. Did you know there is more carbon in the soils on our planet, over 2,500 billion tons, than are in all the atmosphere, all the plants and all the animals on top of the soil combined? So that's a lot of carbon in the soil, and that's where it belongs. And that's where healthy soil will help put more carbon there and store it there. So who cares about healthy soils? Well, hopefully we all do. So what happened to it? Yeah, that's right. So they invented the pyramids and writing. So those are really good things. And about 2000 BC, the Egyptians were using plows, and they were using metal-tipped plows. Now, author David Montgomery, who's written some really good books about soil and the collapse of civilizations, will tell you that ever since then, plows have been tearing up soil and bringing down civilizations ever since. Now, Thomas Jefferson here in the United States actually designed a plow, although he didn't actually patent it, he didn't actually build it. He was kind of too busy being one of the fathers of our country. But John Deere invented the steel plow in 1837, and that was to handle the tough prairie soils in the middle part of the country because the old wooden plows and the old iron plows kept breaking. And we were off to the races. Since then, they've invented discs and cultivators and lots of different ways to plow up and tear up the soil. So what's wrong with that? Well, what happens is you also tear up the mycorrhizal fungi. Those fragile fungi that do so much for those plants gets torn up. And when you cultivate, when you disc, when you plow several times a year, year after year after year, you're destroying the fungal base of that plant community. And that means that your plants are going to be stressed because they aren't going to be getting the nutrients they need. Depending on the species and depending on the soil, some of our plants can get 30 or 40% of the nutrients they need, sometimes more, through that fungi. So when it's not there, they get stressed, they go hungry. If you think about it, historically, those people like Thomas Jefferson used to talk about how soil was played out. That was a big thing back in colonial times. And that happened because we continually plowed that soil, because the nutrients were being taken out by the plants, and because we didn't have the fungus and we didn't have the right balance of fungus and bacteria to help provide those nutrients to keep those plants healthy. So that was the first thing that we've done in order to really change what's going on in the soil, is the plowing and the disking and tilling. And then along came nitrogen fertilizer. In about 1909, a German scientist, Fritz Haber, figured out how to synthesize nitrates out of the air. And he said the air is about 78% nitrogen. We figured out how to synthesize nitrogen out of the air using energy. And that was really important because nitrogen is a key component of TNT. So the explosives, the munitions industries that really prospered in the years before and during World War I found a great use for this science. Now, at the time, when you talk about agriculture, there was a running debate between the biologists who were saying that our agricultural problems that we had were a biological problem, that what we needed to do is take better care of our soil. And the chemists who said the problem is chemistry. There's just not enough nitrogen and phosphorus in the soil. And the way we fix that is by putting chemical nutrients into the soil. Now, they were both a little bit right. Certainly the biologists were right that the soil health was really the problem. They didn't quite understand what we now know about some of the microbes and the bacteria and the fungi in the soil. But they did understand that it was essentially a biological process in the soil, and that was what was giving us problems. The chemists were also kind of right, because by that time, most of the soils had been degraded enough in our country and elsewhere by all the plowing and all the disturbance that they were hungry. The plants were hungry, the soils were hungry. And by adding nitrogen in a degraded soil, you do get more plant growth. What happens is the healthier your soil becomes, the less that nitrogen, the less those fertilizers will help you. And at some point, when you get very healthy soil, the fertilizers won't do any good at all. So, but we had a lot of degraded soil by that time. And so it only made sense that people would look to chemistry to try to fix the problem. Now, that munitions industry really blossomed, especially in the United States during World War II. We were making a whole lot of munitions, a whole lot of TNT, a whole lot of explosives. So we had created these giant factories which could take nitrogen out of the air and bring it to nitrates, bring it into nitrogen. So what happens after World War II? Well, in part, our military leaders didn't want to just let that go. They didn't really need to build so many bombs, but we wanted to have the capacity in place to do that if we ever needed to take on the Soviet Union or other countries. So what happened was we tried to find ways to encourage the use of that nitrogen. The easiest way to use it was in agriculture. And so the agricultural synthetic nutrient nitrogen industry really bloomed and blossomed in the years right after World War II. We had cheap nitrogen and lots of it, and farmers started applying it. And it was working in part because a lot of the soils had been already degraded by that time. So in the 40s and 50s, then we saw more scientists creating pesticides. And some of those were developed during World War II, but the pesticides were chemicals that we found could kill things. They could kill bugs that we didn't like. They could kill fungus that we might not like. They could kill weeds that we didn't want. And so in the 40s and 50s, the whole pesticide industry grew up. And that was designed to address some of the problems that we had created because of our unhealthy soil. But what happened, of course, is that pesticides don't just kill one thing. They kill multiple things. So fungicides don't usually just kill one species of fungus, they kill fungus broadly. So what we had was those pesticides having an impact on the worms, on the nematodes that help build soil structure, also on the bacteria and the fungus in the soil, that depending on the species of bacteria, those actually are vulnerable to some of the different kinds of herbicides, insecticides, fungicides, and the other pesticides that we used. Now, people have been using pesticides for thousands of years. People used sulfur, for example, to try to take care of pests. It was 1910 when the first federal law in the United States regulating pesticides came along. But it was really the 1940s and 1950s before the industry really took off. And we've seen it develop and thrive and grow till today. And those companies figure out ways to make their pesticides more effective. And so that's where we saw genetically modified organisms, the glyphosate resistant species of soybeans and other crops, so that we could plant them and then spray them with something like glyphosate, which is sort of a general killer. And it would kill everything else except the species, the soybeans that we wanted. So we've got very large and growing industry that is contributing to the use of pesticides in different kinds on our crop grounds. So what else we did? Well, a lot of monoculture. In the old days, we used to have horses, and we used to plant oats and some other smaller grains and a mix of things because about a quarter of the farmland that we were using was actually feeding the horses, feeding the oxen. So when we went and moved over to the tractor, then we didn't need that. We didn't need to grow those oats. And so what we've seen is increasingly that our farmers have gotten more concentrated as equipment has gotten bigger and more expensive. They've gotten more specialized. And so things like corn, soybeans, wheat, and cotton, they became the big cash crops. And depending on where you were in the country, typically farmers ended up growing only one or two of those. Well, the difficulty there is if you only have one species of plant that's growing on the ground, you're going to have a very limited variety of bacteria and fungi in the soil, because you're going to have a very limited set of exudates that are going to be going into the soil, and you're only going to be able to support a limited variety of those fungi and bacteria. So the soil health declines because of the monocultures that we're planting, and because we've got very few types of species. We don't have diverse crop rotations. The other thing that contributed was taking livestock off the land. And historically, about every farmer had some kind of mix of livestock, whether it's chickens or hogs or cattle. Almost everybody had a mix of crops and livestock. And increasingly, again, as agriculture got specialized, as farmers were told to get big or get out, they specialized more. And more of the livestock production was moved off the land, and it was moved to large barns, it was moved to feedlots. And so what we saw was a lot less of the cropland had actually animals on it. Well, that's a problem, because one of the things that livestock contribute is that manure and the urea, the P. Those are nutrients, and that's also bacteria that goes in and helps feed the soil. So when we take animals off the land, we don't cycle those nutrients through the livestock. We move the animal off the land, we harvest the crops and take those off the land and take them back to the livestock barn or to the feedlot. And that means we're missing the return of those nitrates, the return of those nutrients that come back through those livestock, but we're also taking off the nutrients that are in those plants that are in the crops that we're harvesting. So all of those together have really contributed to the changes that we're seeing in the soil, because we're stressed the soil by each of the things that we've done. So how bad is it? How bad has it gotten? Well, since colonial times, the scientists think that we've lost about half of our topsoil in the United States. About half the topsoil we've lost. If you look at what we're doing right now, for every pound of corn, pound of grain that we produce, we lose about 6 pounds of soil. That's how much erosion that we have. So it's still continuing. Now, we've also seen degradation of the soil that's left. And so about half of the organic matter in our remaining soils has also been lost. So in part, that started when we started plowing the prairies, which might have had 7 or 8 or 9% soil organic matter. And once you plow them, once you turn them up, you immediately lose a lot of the organic matter because it's oxidized, because it stirs up the bacteria, because they rush in and they chew it up. But it's also been through these practices and through these methods which have steadily reduced the amount of soil organic matter that's in our soil. So not only are we losing our topsoil, we've also seen it pretty degraded. It's not just here. We've seen that around the world. In places we've created deserts out of what once were thriving biological communities because of our management. We've destroyed grasslands through our management. Well, at the rate that we're going, some of the scientists are saying that we may have about 60 years of topsoil left in this country and around the world. 60 years. And that means by 2050, in about 30 years, half of it will be gone. So how important is soil health? How important are those soils? Well, put that thinking cap back on and try to imagine trying to feed 10 billion people on our planet with half as much topsoil. That's 2 billion more people than we have today, trying to feed them with half as much topsoil. Trying to imagine here in the United States, trying to feed over 430 million people. That's more than 100 million more people than we have in the US today with half as much topsoil. The math doesn't look very good. It doesn't work very good. So by this time, I hope you probably are hungry, or at least hungry for some good news. So what I can tell you is we got this. At least we know the solutions, we know the problems, if we correctly identify them, and we know what the solutions are. So first, stop tilling. Whether you're rototilling your garden or digging it within every inch of its soil, or whether you're plowing and disking, we need to stop the tilling because what we're doing is destroying the fungi. We're changing the balance in bacteria and fungi in the soil. We need to provide some armor on that soil so that when it rains, the raindrops aren't hammering those soil particles into submission, that they're actually soaking into the soil. So first, we need to stop tilling. We are making some progress. So no-till, which is a way of not tilling soil on agricultural lands, has been growing over the past several decades, and a significant part of the soil is now managed with no-till. A part of the soil is now managed with conservation tillage. So that means we do just a little bit of tillage where we don't drag things through the whole soil, but we kind of carve it up with smaller blades, smaller disturbances. So we're using conservation tillage on a lot more land, but we're still using full intensive tillage on a fairly large part of the soil in America. So that's the first thing we need to do, is continue to make that progress, to continue to move towards no-till, stop the tilling. So the second thing we know what to do is to provide continuous living cover. We need to continue to feed the soil so the soil will feed our plants. And if you think about it, when you plant a crop in the spring, we're out planting now in April, May, sometimes June, and when those plants are only there maybe 4, 5, 6 months of the year, then those exudates that are getting poured into the soil that are feeding the microbes, are feeding the bacteria, feeding the fungus, are only there for less than half the year. Well, what happens in the rest of the spring and the fall and the winter is you're starving those microbes. So unless you have something green growing year-round, whenever you can have it growing, you're not feeding those microbes, you're starving the soil, and then the soil can't feed your plants. So the second step in order to fix what we're doing is to provide cover crops, to have farmers planting cover crops in the fall, so that over the winter you've got a living plant in that soil. Ideally, what you want is a diverse mix of plants so that you support a diverse mix of microbes in the soil. But certainly we want cover crops on the soil. We are making some progress there. Lots of people are talking about cover crops. But if you look at the cropland around the country, we're still down around maybe 5% of the cropland around the nation is actually planted with cover crops every year. That's been growing. There's a lot of talk, a lot of interest, but we have a long ways to go. The third thing we can do to help build the soil, the health of our soils, is to reduce the use of chemicals. So herbicides, fungicides, insecticides, we talked about those. They kill off more than just the bad stuff. They kill off some of the good stuff. We need to reduce the use of chemical fertilizers because they're just feeding the plant and they're starving the soil. Fortunately, as the soil organic matter rises, you need less and less fertilizer. And once you get your soil back to full health, you need no additional fertilizer. So it does take a transition. You can't just go cold turkey. You have to rebuild the health of your soils first before you can take the fertilizers away, or otherwise you're going to have stressed plants living in stressed soils that are going to be starved of the nutrients they need. We're making some progress there in the United States. What we're seeing is not a huge decline in the use of fertilizers, but what we're seeing is more production from the same amount of fertilizer. And what that means is we're using it more efficiently. We're not wasting as much of it, and that's a good thing. But we still have a long ways to go. We still have a lot of farmers who are spending a whole lot of money buying chemical fertilizers because they need it in order to subsidize the soil health that's not there. So we also need to incorporate livestock back on the land. Manure and animals have always been part of the system, and they need to be returned to the system. Now, what they do is they supercharge soil health. The bacteria and the nutrients in that animal, in those animal droppings, in the manure, in the pee, actually helps supercharge the bacteria and the fungi in the soil. So it's important to put those livestock back on the land wherever we can, incorporate them back into certainly in our grasslands where they're already at, but also on our croplands. We also need to use more rotational grazing systems. We need to keep the animals moving, which is historically how the big bison herds, how the deer and the elk managed the land, is they kept moving around. What that does is give plants plenty of time to recover, to build those leaves, to rebuild the plants, to build those solar panels to capture more energy. So that's what we need to do in terms of livestock, is we need to use more of those rotational grazing systems where we keep the animals moving. What we're seeing in our country is about a fifth, about 20% of the grasslands of the folks who have pasture are managing it with those rotational grazing systems. That number hasn't moved very much over the last 10 years. So we have a lot of opportunity there. We have a lot of need to really restore the health of our grasslands. So how do you know it when you see it? How do you know that your soil is healthy? Well, if it's in your soil, if it's in your garden, your yard, or your farm, there are some simple tests that will help you. And in fact, on our website, we have a blog and a video, 5 super simple soil tests that will help you understand the health of your soil. There are things like counting the worms and nematodes that are in the soil, like measuring the water infiltration, how fast it is, measuring the biological activity in the soil. So check it out. That will help you understand the health of your soil. Now, traditional soil tests are really testing soil chemistry, not soil biology. So they're really not very helpful when we're talking about soil health. There are some new tests. There's the Haney test. Cornell University has a comprehensive assessment of soil health test. The US Department of Agriculture is evaluating testing protocols for soil health. And all of those are new kinds of tests that are designed to understand the health of your soil, the biology of your soil, to look at the balance between fungi and bacteria and the types of fungi and bacteria and other things you have living in your soil. So that's one way you can do it, is there are actually now a growing number of soil tests which will help you understand the biology. But what if it's not your land, if it's not your soil? What if you're a stream monitor, or you're just out in the neighborhood, you're looking at a watershed and you want to know how healthy is that soil? How healthy is that soil? Well, you can't tell for sure without digging in. But one way to read a watershed is to look for the clues. So first, what does the soil look like? Do you see lots of dark, smooth, rich soil that looks like you just want to plant in it? That's actually a bad sign. In fact, if you can see the soil, that's a bad sign. It probably means the soil's been disked or plowed, the residue from last year's crop has been turned in, or maybe it was just baled and removed, taking the nutrients off site. And it means that there's not any armor protecting that soil from the rain and wind. As I said, rain will batter the soil, breaks up the structure. Rain, wind, and snow melt can then carry your soil away, taking whatever nutrients and manure are there. What you want to see is a covering that looks something like a mulch protecting the soil. So if you're looking for healthy soil, look for soil that is covered, soil that is armored. So what color do you see out there? You should see green, whether it's summer, spring, fall, even in the winter. Ideally, you should see green. That means there's green, growing, living plants there. That means those plants are pumping exudates into the soil, feeding the microbes year-round. And that means that you don't have a situation without cover crops, where we're just planting there in the summer and we're basically starving those microbes for most of the year. So you want to see cover crops in the fall and the winter and the spring. And ideally, you want to see a variety, a mix of those cover crops, not just one. If you look out and all you see this time of year or in the fall, all you see is brown, or worse, all you see is bare soil, the soil is probably not very healthy because the microbes are being starved. So look at the equipment you see in the field. Take a close look. If you see tractors dragging a trailer, these big round discs that carve into the soil, or something that looks like plow blades turning up the soil, that's a bad sign. It means they're not practicing no-till. Those discs or plows are tearing up that mycorrhizal fungi in the soil. Well, if you're seeing those big anhydrous ammonia tanks, those big oblong tanks, usually on trailers, that means we're still relying on chemical fertilizers. Now, you probably don't know how much they're using, so don't jump to conclusions unless you see them in the fall on bare ground. Now, nitrogen fertilizer applied in the fall generally moves down through the soil. It moves down through the root zone, and by the time you plant in the spring, it's moved fast enough that it's below the place where it will help your new plants. By the time in the summer when your plants could use those nutrients, it's moved down even further. So the nitrogen that's applied in the fall is mostly wasted, but it's not just wasted, it just keeps going. It keeps going till it lands up in the groundwater or until it comes out at a spring into your surface water. So that's a bad sign. Do you see fences around the sign? Now, fences around the fields is really a good sign. It can be. It means the landowner may be putting livestock on the land over the winter, maybe to graze off the corn stalks, and that can help you boost soil health. Now, that's especially true if what you're seeing is green cover crops that are growing over the winter that livestock can eat. So fences, especially fences in good repair, that's a really good sign. Now, if you've got grasslands, look at the grasslands. Someplace where cattle and sheep are grazing, look how they're managed. If you see fences with the animals in just one section, that could be a good sign. If they look like they have plenty to eat, if the grass is growing up to the eyes of the cow, that's also a good sign. It means they have plenty of forage there. If you see plants in different parts of the pasture or at different heights, some tall, some medium, some short, that's another good sign that the landowner is practicing rotational grazing, that they're moving those animals around. If you see a grassland out there that looks like a golf course or a carpet, that looks like the animals are grazing it like right down to the ground, and when you see the animals are allowed basically to move wherever they want around the pasture, that's a bad sign. It means the plants are likely to be stressed, they're likely to be weak, shallow rooted, and the owner's probably not getting very good production out of the land because they're not managing the soil, they're not managing the plants in the ways that provide the most production and boost the health of the soil. So with a little bit of practice, even you can go out and you can read the health of the watershed that you're in. If it's a rural watershed and you have farms and ranches, you can go take a look and see what things look like. So to wrap this up, so what else can you do? Well, if you're not dazzled by the magic of soil health, if you don't see why everyone should care about soil health, then hit rewind, watch it again, maybe it'll take the second time. What you can also do is you can change what you're doing. Whether you have a farm, a ranch, an acreage, a garden, or just a potted plant, you can change the way you're managing the soil. You can adopt these soil health principles, and what they'll help you do is build healthier soils, and then those healthier soils will produce healthier plants. You can also tell people about healthy soils. Talk to your friends, talk to your relatives, tell them how exciting this stuff is. You can talk to your member of Congress, your state legislator, your county conservation district manager, tell them why you think they should be promoting healthy soils. You can see why healthy soils are so critical to our future. They're so critical to the food we eat. They're critical to the environmental challenges that we face. So we need to get more and more people talking about and understanding healthy soils. You can volunteer with the Isaac Walton League. Now the League is working at the federal level to advocate for policies that promote soil health in Congress and with federal agencies. You can help us by contacting your member of Congress. We're working at the state level to advocate for these same kinds of policies. We're trying to educate state legislators and state officials about soil health so they understand that the policies they adopt can have a huge impact on the soil beneath our feet. We're also looking for help at the local level. So help contacting our county conservation districts to support their efforts to help educate farmers, ranchers, and other landowners about healthy soils, because it really starts very local in terms of rebuilding our soil health. So if there's an Isaac Walton League chapter near you, you can help us with local conservation efforts, including soil health, at your local chapter. You can also join our Soil Matters email list. That'll get you updates on soil health in Congress and elsewhere. To do that, you can visit our website, www.iwl.org, and you can sign up for our Soil Matters email list, where you can learn more about soil health and some of the things that are going on. And of course, you can talk to your friends and relatives. You can help them see the magic that is soil health. So thanks for your time. I look forward to any questions you have.
All right. That was great, Dwayne. Definitely learning a lot about soil. There's just so many aspects to the world of soil health that I was not even aware of before meeting you and hearing about all the different work that you're doing that you've heard about. So thank you. This is very interesting, and it's nice to have ways that I think private citizens can also get involved and feel like this is an issue they can engage with too. So we have some questions that were coming in. So we'll be spending some time doing Q&A. And one of the first things I did want to bring up and ask about is, we talk about soil runoff and, that can get into rivers and streams. What exactly does it do when sediment or fertilizer or this runoff enters streams, and why is it bad for our waterways too?
Yeah, it can cause a host of problems. So the sediment itself can fill up reservoirs. So those reservoirs and lakes that we have can get filled up by the sediment. The nutrients, so the nitrogen and phosphorus, can actually feed the algae in the water. And so there is always algae that naturally occurs, but when we feed it artificially high levels of nutrients, then you get these big algae blooms. And once they bloom, then they die. And then the decomposition sucks up the oxygen in the water. And so we see it from small ponds to community lakes, all the way to Lake Erie and the Gulf of Mexico and the Chesapeake Bay and other places around the country where those excessive nutrients have gotten into the water, have caused these algal blooms. Sometimes they're poisonous blooms, as we saw with Toledo a few years back, but they also create a dead zone in some of those waters where we lose the life around it that depends on the oxygen in the waters.
Yeah, and something else we definitely see with our stream monitors is when there's a lot of soil runoff, it can also clog up streams and change habitat types. So we look at macroinvertebrates, the bugs that live in the stream, and a lot of them rely on having cobbles and nice little riffle areas to hide and hunt in. And when you get a lot of sediment, it totally blocks it and changes the habitat. So some areas that had rocky streams then become much more muddy bottomed, and it really can alter the stream and its life history.
And it's a real problem for those macroinvertebrates. It's also a problem like for trout. Fish like that need that rocky bottom stream in order to reproduce. And if that sediment coats it and you get a muddy bottom stream, then fish like trout can't reproduce. And so then we lose them.
Yeah, it's all connected. So we had a couple of questions about livestock in particular, because some folks were asking about, used to hear that having too much livestock out in the fields would compact the soil and could damage the soil. And now we're hearing that, it's better to have livestock out there. And there was also some question about, there's growing concern about antibiotics and hormone use with cattle and with other livestock. So what is the balance in terms of bringing livestock onto your fields while also knowing that there could be some added issues with having more animals out on the land?
Sure. So the compaction can be an issue. It's an issue so the less healthy your soil is, the more vulnerable it is to compaction. If what you have is a lot of those glues and exudates that are sticking your soil particles together, you have pretty firm soil. So even when it gets really wet, you can still walk on it, cattle can walk on it, and you're not going to compact the soil. So if you have those issues, what you're seeing is a symptom of unhealthy soil. So bringing the cattle back onto the land is actually a good thing. It'll help rebuild the health of that soil, and it'll help rebuild the soil structure. If you're plowing it and disking it too much and you're breaking up those soils, then when you put cattle on it, you are going to get some compaction. So you need to manage it differently. So you need to manage it with the livestock. And that'll help address a lot of those compaction issues, is rebuilding the soil organic matter, rebuilding the structure in those soils. With respect to the antibiotics, that's really a symptom of the production system. If you put 10,000 hogs together in a barn, that's not a very healthy environment. So what happens is you have to use a lot of medicines, antibiotics and other things, in order to deal with the sickness and the illnesses that you create, because you're stressing those animals and you're putting them all together in a place. In some cases, with chickens, with beef, with some other of our livestock, we're actually using antibiotics at a real low level to try to stimulate growth. And so, again, that's all bad for us, because some of those same antibiotics are things that we as humans need to address things when we get badly ill. And when we have more of those antibiotics out on the landscape, it means that those bacteria, that the things that those antibiotics are designed to kill, eventually find ways to adjust and adapt. So it certainly is an issue. What you find is that the farmers who have cattle on grass in rotational grazing systems, they don't need the antibiotics. They don't need the dewormers. All of the chemicals that we use in order to deal with some symptom of the problems with those livestock, by putting them back in a more natural environment, putting them back on the grass, by moving them regularly, by managing the grass and the animals, you really reduce and eliminate a lot of those problems that we've created by putting too many animals together in one place.
Great. We also had some questions from folks about both from farmers who might be interested in transitioning to no-till and cover crops, and also folks who might want to help gather resources and educate, their local community. Is it difficult to transition to a no-till and cover crop style of farming? You know, for a lot of farmers, if they're living, you know, season to season, it might not have enough the savings or the ability to absorb, you know, a season or two of transition. Is it something that's economically feasible? How would that work if you're a farmer who knows that this is an issue and they want to transition, but it might be a little scary to start that transition?
Sure, change is always scary. And in this case, if you think about it from a farmer's perspective, every time they put a crop in the ground in the spring, I mean, they're literally betting the farm that it's going to work and that they're going to get a good harvest in the fall. So you certainly understand that farmers are very careful about the risks that they take. And this is an area where typically the return on these soil health practices, sometimes they get the same return that year. So they pay for themselves. Some of the practices like no-till can pay back for themselves pretty fast. In other cases, the soil health practices, the economists who have really looked at this are saying typically in maybe 2 or 3 years, you can recoup those investments that you make in some of these soil health practices. And then after that, it's gravy that you're ahead of the game. There is some transition, so you don't want to just blindly go into it. You want to learn as much as you can about the practices, about how they work in your soils and in your climate and in your area and with the kind of crops that you're using. So you do need to think about it. There's also some federal and state programs that are available to help with the investment part. And that's, I think, one of the biggest obstacles. If you're moving from grazing a whole pasture to grazing pieces of a pasture, so rotational grazing, you've got to think about fencing, you've got to be able to get water into each of those pastures. So those are some investments you have to make in order to change the system. If you're going to no-till, you may need a no-till seed drill to either buy one or borrow one or rent one. So there are some investments. There are federal programs, and that's one of the things we do at the Isaac Walton League is support those federal and state programs that help farmers cover at least a share of the costs of making those investments. So the programs are out there, they are available, and they're one way of helping farmers reduce the risk by letting them attain a share of the cost of making those investments they need in order to make the transitions.
That's great. So we have time for 2 more questions. There are lots more questions coming in, and I'll be sure to share Dwayne's contact information in our chat box if you have more questions that you want to send him. So our first question that we have is, in terms of our private landowners and private citizens, you know, some of the practices they might do at home. So folks were asking about using natural manure at home, you know, even if they have goats. Someone mentioned that they raise, you know, what is the best way to practice applying natural things like manure or fertilizer at home? So like with fertilizer, if you can go to Lowe's or Home Depot and purchase fertilizer, is there a responsible way to apply that? Should you not be applying it at all? What should we each do sort of in our own homes and yards and gardens?
Well, if you practice some of these soil health principles and practices, so if you stop tilling, if you plant cover crops in your garden, whenever you see bare soil, make sure that you plant something in there that will come up and help feed the soil. If you start practicing those soil health practices and do the kinds of things we talked about in your garden and in your yard, and we've got some blogs on our website that will explain things you can do in your yard and your garden to boost soil health. Then you won't need the chemical fertilizers. You won't need to buy the fertilizer from the store. If you're looking for nutrients, especially to help get you started, things like composted manure, organic matters like those will be helpful. And if you put those on your soil in your garden, that will help you get started. You also want to compost, you know, leaves or grasses or anything like that. Ideally, what you want to do is just compost those right in the yard. So use a mulching mower that leaves the nutrients there. But, you know, compost your food waste and things like that, and then put that compost on your gardens. And so those are the kinds of things that will help feed the soil. What you're looking for is to try to really build up the organic matter in that soil And once you've got it there, then the soil will feed your plants.
Great. And last question. I know there's still more coming in, so definitely reach out to us if you have more questions. We'd love to keep engaging with you on this issue. Dwayne is a real expert on the umbrella of agriculture issues. But so the last question we were getting from a lot of folks are, what are some recommended books, films, resources? Folks mentioned particularly if they want to educate kids or family, but others were talking about, what are some books that you found that are really helpful, or if there are movies, documentaries, what are some resources that people can start to use to learn more about this issue?
Sure. Well, there's a lot of good stuff, a growing body of things that are out there. David Montgomery has several good books. I think one's on soil, which is about the collapse of civilizations. He's also got a new book that's about regenerative farming and the things that we can do, a vision for really a better future on the landscape. So that's one place I would look. There's some really good recent movies. One of them was about a farm in California. I think it's called The Biggest Little Farm. Now, it's a different situation than almost everyone faces, but it's a beautiful film, and it really takes you through kind of year by year the challenges that this small, a family on a small farm faced as they were trying to build the soil health. So it's funny, it's a beautifully shot film, but that's a good one to see. So I think you can also look on the internet if you Google on YouTube. So if you look for people like Gabe Brown, G-A-B-E, Brown. Gabe's a farmer in North Dakota that's got some great soil health videos. Ray Archuleta, A-R-C-H-E-L-U-T-A, something like that, E-T-A. Ray is a former USDA soil health guru, and he's got a lot of good videos out there. David, what's David's name? And so if you Google those two guys, what you'll find is some really good soil health videos. If you're interested in grazing, Greg Judy is a guy in Missouri. Greg Judy, who has some really great videos, a whole series of them that he does, kind of a web blog, where he talks about what he's doing on his place in Missouri to do better grazing operations. And he's got he's very really practical solutions and practical ideas for the kinds of things he does. So I guess there's some places to get started. We'll probably be putting some of these resources, some links to these on our website. They're not there right now, but look for it in the future, and we'll try to put some of the best books, movies, and videos that we can find.
Yeah, so I put a few of those names in the chat box if you want to copy and paste them now, or I'll also include in the follow-up email you'll get in a few days some of these resources too. So definitely keep an eye out on those. You can always reach out if you have resources that you like as well. Well, that's our hour used up. Thank you so much, Dwayne. This was such an engaging and interesting presentation. I know it's an issue that a lot of folks sort of have an inkling about, but might not have known so much about the history or even just some of the how and why in terms of soil health and how we got where we are. So this webinar was recorded for those of you who are wondering, and you'll get access to that recording soon. Otherwise, definitely check out our website, iwla.org, and you'll see lots of our soil health initiatives and things that Dwayne has been working on, particularly with policy and agriculture. And otherwise, we hope to see you all for our next Clean Water webinar. We're actually taking next week off because next week we're launching our online training program for folks who want to become Save Stream monitors. So definitely check out the website. We'll be offering 4 live webinars, presentations, and training classes. The week after, we'll be jumping back in with our webinar series, and the topic will be about communicating science effectively in terms of your findings and your data that you collect. So that'll be really cool for folks who are monitors or folks who are gathering and want to communicate their findings and their data to a wide audience. So thank you again, Dwayne. This was great. and hope to see all of you at our next webinar in 2 weeks.
Thanks, everybody.
Thank you.